Welcome back to Breaking Math. I'm your host, Autumn Fineff, and today we're talking about something so fundamental that we often take for granted, measurements. From the seconds ticking on your clock to the weight of your morning coffee, measurements shape every aspect of our daily lives. But have you ever stopped to wonder, what if different places use different definitions for the same measurement? What if a kilogram in one country wasn't the same as a kilogram in another? Or even worse, what if a second wasn't a second everywhere? Today, we're diving into the fascinating world of measurement, how we measure things, and why we need precise international standards, what happens when things go wrong. And excitingly, this episode is part of a mini-series where we have had the opportunity to chat with some amazing scientists from the National Institute of Standards and Technology, or NIST. NIST is one of the world's leading organizations in defining and maintaining measurement standards, and we'll be featuring their expertise throughout this series. So let's get into it. Let's start with the basics. A measurement is a way of quantifying the world around us. It allows us to assign numbers to properties like length, weight, or temperature so we can compare them. It seems simple enough, right? But measurement is more than just using a ruler or stopwatch. It's a fundamental part of how we communicate scientific discoveries, build technologies, and even conduct business. Imagine if everyone defined measurements differently. What if one scientist's meter was slightly longer than another? Chaos. The solution? Standards. And that's where the International System of Units, or SI, comes in. The SI system is a globally agreed upon set of measurement units. It includes 7 base units: the second time, the meter length, the kilogram mass, the ampere electric current, the Kelvin temperature, the mole, the amount of substance, and the candela, luminous intensity. These form the foundation of all science and engineering. These units are not arbitrary. Take the second, for example. You might think of a second as just 1/60th of a minute, but the SI system defines it much more precisely. A second is the time it takes for a cesium-133 atom to oscillate 9,192,631,770 times. This level of precision is critical for things like GPS, financial transactions, and internet synchronization. Now, what happens when measurements aren't standardized? History has given us some costly lessons. One of the most famous cases is the Mars Climate Orbiter disaster of 1999. NASA engineers used metrics for calculations, but one of their contractors used imperial units, pounds instead of newtons. The result? A $125 million spacecraft burned up in the Martian atmosphere because of a simple measurement mismatch. Another example, in 1983, an Air Canada flight nicknamed the Gimli glider ran out of fuel mid-flight because fuel calculations were done using pounds instead of kilograms. Thankfully, the pilots pulled off a miraculous unpowered landing, but it was a terrifying reminder of why standards matter. Now, let's talk about NIST. The National Institute of Standards and Technology is a U.S. government agency responsible for maintaining and improving measurement standards. NIST ensures that everything from timekeeping systems that synchronize the internet to the precise measurements used in pharmaceuticals is accurate and reliable. NIST scientists work on some of the most cutting-edge advancements in measurement science. For example, they're improving atomic clocks to measure time more accurately than ever before, down to the billionth of a second. This level of precision helps with everything from deep space exploration to the synchronization of financial transactions. Over the next few episodes, we'll be talking to experts from NIST who are working on various aspects of measurement science, including quantum computing, time, and fire science. Stay tuned for interviews and deep dives into some of their groundbreaking research. Now, measurements are still evolving, if you didn't know. In 2019, the definition of a kilogram was officially changed. Instead of being used on a physical metal cylinder in France, it is now defined using Planck's constant, a fundamental constant of physics. This shift ensures that our measurements stay precise no matter where or when you are in the universe. As technology advances, we're pushing measurements to new frontiers. Quantum computing, ultra-precise atomic clocks, and even a question of what is life. The future of measurement is bright, and the more precise we get, the more our world and maybe even the universe will make sense. But measurement isn't just for scientists. It affects you in ways you might not even realize. The food you eat, the gas in your car, the devices you use. Every single one of them relies on precise measurement standards. Even timekeeping, which seems so natural to us, is carefully regulated using atomic clocks and synchronized worldwide. So the next time you set your watch, weigh some ingredients, or check your car's speedometer, take a moment to appreciate the vast interconnected system of measurements that keeps our world running smoothly. Standardized measurements is one of the unsung heroes of modern life, and it's what makes everything from science to trade to space exploration possible. And don't forget, this episode is just the beginning of our mini-series that introduced you to NIST. We'll be bringing on real scientists from NIST to talk about their work, from cutting-edge atomic clocks to how measurements of radiation affects food. If you have any questions about measurements, feel free to tweet us at Breaking Math Pod on X, and we might even ask them in our upcoming interviews. So if you've enjoyed today's little mini episode, don't forget to subscribe to Breaking Math. You can also support the show by sharing it with your friends and following us on social media. Until next time, keep questioning, keep learning, and keep measuring.